Section 7.7, base E and natural logarithms. So E is just a constant, kind of like pi. We know pi is 3.14159, and it continues going on and on forever. E is just like that. It's a constant. It represents an irrational number, which means it goes on forever and ever and ever. And the number is 2.71828. There actually is an E button on your calculators. So here's your calculator. And E is located on the division sign. So if you press second and E and press enter, it will tell you what E equals. 2.7182818. Okay, it'll continue to go on forever. E is used quite a bit in chemistry and in logarithms especially. And instead of writing something with a log that has a base of E as log base E, instead we write it as ln. It's just a shorter, more concise way to write it. And as I've been saying all year, logs are just another example of this. Mathematicians try to find ways to shorthand things. They don't like to write things long. That's why we have a lot of understood ones and things of that nature. So this is just another way to shorten that up. How can I actually use E? Well, it follows all the same things that you did in previous sections with logs. So when we translate into the opposite form, we can still use our loop just like we did in section 7.3. Log base E, which we know we write as ln. Go around the equal sign, so of 30 ends at the number next to it is x. If we want to go the other way and write it in exponential form, ln we know means has a base of E, so go around the equal sign, end at the number next to the x. Base of E to the 42nd is x. Okay, let's do one more of each kind of problem. Start at the base, go around the equal sign, and at the number next to it. So log base E, which we know to be natural log, of x is 3. How about this one? ln, or natural log, of 18 is x. We know that the base of natural log, or ln, is E, around the equal sign, so to the x equals 18. So you should be able to convert back and forth between them. Let's take a look at some other problems. We're going to skip this because we did not cover those properties and move down to these. Solving an equation, and we're not doing inequalities, but solving an equation to the nearest 10,000th. So the first thing that we need to do is add 24 to both sides. Just like a normal equation, you're going to do as much as you can to get that x by itself. And when you run out of moves with your regular algebra that you had learned previous to this year, we're going to use logs. So we're going to add 24 to both sides. So we have 5 times e to the x equals 40. Divide by 5 on both sides. And now I've kind of exhausted my normal solving methods to solve this. So in comes natural log. Whenever you get something raised to a variable, it's probably a good idea for you to go ahead and change to logs. So I'm going to draw my loop. Log base e, which we know we write as ln, of 8 is x. So equals x. ln of 8 is something I can actually use my calculator to calculate. Your calculator has a button for natural logs on here, just like it has a button for logs with base 10. The button is actually located right underneath that button as ln. So ln of 8, close your parentheses, and we get our answer. X is equal to 2.0 2.07, I believe we're going 4 decimal places, so 2.0794. Let's take a look at the next one. This one we are going to work to get this e to the x all by itself. So that means I have to subtract 9 from both sides. Divide by -3 on both sides. And I've got that e to the x by itself. I'm kind of out of all of my steps. I can't add, subtract, multiply, divide to get x alone. I have to use logs. So draw my loop. And if I was using logs, I would have log base e, which we know is natural log, of 5/3 is x. Now it's something I can put into my calculator because my variable is alone. ln of 5/3, close your parentheses. So we get 0.5108. Let's do one more that looks like this. We have to first subtract 4 from both sides. Then we're going to divide by 3 on both sides. And let's draw our loop. Log base e, which we know is ln of -4/3 is -3x. You may have remembered from my previous video that we can't have a log of a negative number. As a matter of fact, when we go to type this into our calculator, we have ln of -4/3. It's going to give me this weird imaginary number because my calculator is actually programmed to do imaginary numbers right now. If I change it back to real answers, it'll actually give me an error and say it's a non-real answer. That's because you cannot raise a positive number to any kind of power and get a negative answer. That's why you can't have a log of a negative number. So this actually has no real solutions, or you can say no solutions. Now let's try some that are already in natural log form that we will need to change over to exponential form to solve. You know that it's time to change it into exponential form when you have one natural log all by itself. That's what we have in D. Natural log of 3x. That's the only thing on the left side. So that means I'm at a point where I need to change forms. So drawing our loop would mean I would have natural log, that's a base of e, to the 8th power equals 3x. Now, if you looked right above the ln button, you would see an e to the x. So you can use either that button, or you can do the division button and then raise it to the exponent. Either way, you'll still get the same answer. Second, e to the 8th power, and we get 2,980.95, and that 9, the 8 that comes after the 9 makes it round up. So that will make this 9,580. And that equals 3x. So I need to divide by 3 on both sides. And remember, we want to keep that whole number in there, so just press divide by 3. We don't want any rounding errors. And by keeping that whole number in there, that means that I'm not using this. I just wrote down the correct rounded version so that I could make sure that you indicate when the 9 travels up that you actually will look like you've only rounded to 3 decimal places when really you have done 4. Let's take a look at E. Again, in order to switch to the other form, I need to get rid of that -4. So there's 2 different ways that you can go about this. Right now, you can read this as -4 times natural log of 2x equals -26. And reading it that way might indicate to you, hey, I should divide by -4 on both sides. Or you can look at it as, remember the power property, which would indicate -4 would need to be an exponent for this. I personally think it might be easier for us to divide off the -4. So that's what I'm going to do first. Natural log of 2x is equal to, and 26 over 4 simply reduces to 13 over 2. Now that natural log is all by itself, so I can switch forms. So I'm going to draw my loop. Base of E around the equal sign ending at the 2x. So I have E to the 13 halves, or 6.25, whatever makes you happy, equals 2x. Well, I can type E to the something into my calculator. E to the 13 halves, I get 665.1416 equals 2x. Let's divide that by 2 so that x is equal to 332.5708. Take a look at the next one. I changed these all to equations. They were inequalities, but just for the purposes of having some extra problems to work through, we changed them to equations. And F already has the natural log all by itself. So we can change forms. So I have E to the 6th power equals x plus 5 squared. Well, I can figure out what e to the 6th power is. That's on my calculator. Second and the natural log button, e to the 6th power gives me 403.4288. And that equals x plus 5 squared. Don't bother trying to FOIL this out because we need to get rid of the square anyway. So we are going to square root both sides. You could have done the powering property from the beginning and moved the 2 in front and divided by 2 on both sides. Either way, you should still get the same answer. So I'm going to press second square root in my calculator. And then second answer, remember that's the negative button at the bottom. And I get 20.0855. And that equals what x plus 5 is. So subtracting 5 from both sides means that I'm going to end up with 15.0855. Okay, let's go ahead and turn the page here. Just a couple quick problems up top, and then we're going to do a few word problems. You already have a couple word problems printed on your notes, and then I do have just 3 more that I want to walk through so that we get plenty of word problem practice before our quiz. So the log is already by itself. This time I'm going to use the powering property just so that we have a little change of pace here. So that means I'm going to move the 3 here. If you don't want to do the powering property and would prefer to just change forms, that's up to you. But since it's a similar problem to what I just did, I'm going to try the other way to solve it. So that means I have to divide by 3 on both sides. And I have natural log of x minus 2 equals 5. And now it's time to change forms because my natural log is alone again. So e to the 5th power equals x minus 2. We can calculate out what e to the 5th power is. Second natural log, 5th power. And that gave us 148.4132 equals x minus 2. So I need to add 2 to both sides. So that x equals 150.4132. The next problem is an exponential form, and that e to the x is all by itself. So it's time to change forms. Notice we changed all 3 problems in the back here to equations. So natural log of 29 equals x. So all I have to do is type in ln in my calculator, not the second this time, just ln, 29, and I get that x is equal to 3.3673. Sorry, that lighting kind of gets all funky. Next one. I have to get rid of the 5 in front. I can't change forms with that 5 hanging out in front because that 5 is not part of the e to the negative x. So I'm going to subtract 5 from both sides. And I get that e to the negative x is 9. Now let's change forms. So I have natural log of 9 equals negative x. I can type natural log of 9 into my calculator. So I get 2.1972 equals negative x, and divide by negative 1 on both sides so that x is equal to negative 2.1972. Now on to the word problems. In order to work these word problems out, we do have to introduce one more equation that's given on your cheat sheet. Here it is. It's the equation for something that is continuously compounded. And so A is the amount in the account, P is still the principal, R is still the rate, T is the time. The difference is E, it's not a variable. This is really standing in for 2 point blah, 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 blah. Okay? So when I look at this word problem, and I'll zoom out just a little bit so you guys can see the whole word problem. But when Angela was born, her grandparents deposited $3,000 into a college savings account, paying 4% interest, compounded continuously. This right here is our big clue. This tells us we should be using the formula A equals PERT. Okay, assuming there are no deposits or withdrawals from the account, what will the balance be after 10 years? And it went ahead and told us to go ahead and use this formula too. But even if that part wasn't there, the compounded continuously tells us to do PERT. So A, P, R, and T are the variables that I'm going to need to find values for. We're looking for how much the account is going to be, so that's going to be my variable I'm looking for. They put $3,000 into the account. That's my principal. It's paying 4%, so that's 0.04. And the time is 10 years. So let's plug this all in. We have A equals 3,000 times E raised to the 0.04 times 10. I can type that all into my calculator all at once, or I can do it piece by piece. I'm going to choose to do it piece by piece for you so that you have an option. 0.04 times 10, that gives me 0.4 Then I would need to do the exponent next. So e to the 0.4 power. Second natural log, 0.4. And then I need to multiply that by 3,000. So my final answer I see what I did wrong. I typed -4 instead of 0.4. See, if we were all in class, you guys would have called out and told me. You wouldn't have let me sit here and figure out why my answer was wrong. So let's try that again. Sorry. Second natural log of 0.4. That's much better. Times 3,000. Now, that actually is a really great example of what you could do on a quiz. Now, if Angela's grandparents put money into an account and left it alone for 10 years, you would expect for the account to be bigger than the $3,000 that they started with. So my answer, it wasn't bigger than the 3,000. So that indicated I did something wrong and I should go back and look. You kind of have to take a moment when you're doing these tests and quizzes, especially because some of them may be multiple choice on these ones that you're doing online. You need to take a minute and make sure, is my answer reasonable? Is it reasonable for her to go from 3,000 to 4,000 with just a small interest rate of 4% over the course of 10 years? That's pretty reasonable. If it said 3,000 to 35,000, I'd think, that's probably not reasonable. I should go back and look. Or if it got smaller, again, that's not reasonable. Go back and look. So, good example coming from my bonehead mistake. Let's take a look at the next one. How long will it take the balance to reach at least $10,000? Well, APRT again. This time they want the ending account balance to be $10,000. We're still starting with 3,000. We're still using an interest rate of 4%, but this time we're looking for time. So let's plug all that into the formula and see what it looks like. 10,000 equals 3,000 times e to the 0.04t. Now I can't just toss it all into my calculator. I actually have to do a little bit of solving. But these now look exactly like what we did at the beginning of the notes. We're going to divide by 3,000 on both sides. So I have 10,000 divided by 3,000. And it's still going to be a fraction. That's okay. I would choose to use the fraction instead of the 3.3 repeating. So we're going to have 10 thirds. And notice now we have e to the something all by itself. So I'm going to change forms. And we have ln, because log base e is not written as log base e, it's written as ln, of 10 thirds equals 0.04t. You might be noticing that my loop went the other way. That's because I always ask you to go around the equal sign first. So it wouldn't make sense for you to go all the way around this way. We're going away from the equal sign. You always want to go into the direction of the equal sign. So when the e is on the right-hand side, it makes my loop look opposite. So in my calculator, I'm typing ln of 10 thirds 1.2039, which means 9 also rounds up, so it's 0.04. Then I need to divide that by 0.04. Now, what would we think would be a reasonable time frame before I press equal? Well, we know that after 10 years, she was only at 4,000 and some change. So we know that our answer should be much bigger than 10. So if you're getting an answer that's less than 10 or something that's like 11 or 12, you're probably not doing it right. You want to go back and check your work. As a matter of fact, the answer is it would take over 30 years. So I would accept either saying over 30 years or you can say 31 years. Even though this doesn't round up to 31, we can't say that it takes 30 years because they wanted it to be at least $10,000. And 30 years would just be shy of $10,000. So the next part is the word problems that you don't actually have in your packet, but I still thought they would be good practice. So a virus is spreading through a computer network to the formula of 30 times e to the 0.1 t. V is going to be the number of computers infected. T is the time in minutes. They want to know how long is it going to take the virus to infect 10,000 computers. So we want to know when is it going to equal 10,000. And we have 30 times e to the 0.1 t. So I need to first divide by 30 on both sides, just like I did in the previous problem. So I have 10 over 3 equals e to the 0.1 t. Now that that e is all by itself, I'm going to change to the other form. Again, the e's on the right, so when I draw my loop, it's going to look opposite from what you're used to looking at. We have natural log of 10 thirds equals 0.1 t. So natural log of 10, natural log of 10 thirds. And then I need to divide that by 0.1 to get that t by itself. So t is equal to 12.0397. And that's how long it would take. It would take 12.0397 minutes. Or if it was an inequality, you would be able to say that it would take 13. Otherwise, you should probably leave it as that. Two more that go back to our word problems that have to do with money. If I invest $3,000 compounded continuously, that tells us to use APERT, at a rate of 2.6%, how much will I have in my account after 4 years? So APRT, how much will I have? I had 3,000 to begin with. The rate was 2.6%, so that makes it 0.026. And the time is 4 years. So let's toss that all into our formula. A equals 3,000 times e to the 0.026 times 4. Since I worked the previous one out step by step that looked like this, I'm going to just show you how it would look if you tossed it all into your calculator. So we have 3,000 times e to the 0.026 times 4. And we would have 3,328.80 because we want to round to dollars and cents. Last one. If I want to earn $1,000 by investing money that earns 3.4% interest compounded continuously, for 5 years, how much will I have to have in the account right now? So that compounded continuously tells me APERT. So I have APRT. I want to earn $1,000 by investing money that earns 3.4% interest compounded continuously. So I'm just going to put $1,000 here. I know that that will technically be the amount in the ending account and not the technical amount that you earned. I just think that that's a technicality at this point. I'm not going to make you subtract off what was there. We'll just say I want to have $1,000. Earns 3.4%, so 0.034, 5 years, which means I'm looking for the principal. So I have 1,000 equals P times e to the 0.034 times 5. Now, I'm actually not going to need to use logs in this case because I could type into my calculator e to the 0.034 times 5. I get a number. It's not pretty, but I do get a number. And then all I have to do is divide 1,000 by that number, and I get what I started with. So 1,000 divided by 1.1853 gives me that I needed to invest $843.66 if I wanted to end with $1,000 in my account after 5 years.